Alright kids, first things first. First video I'm making for you, be gentle. The inverse square law, I know a lot of you guys are struggling with that. So I'm going to do the multiple steps that make it easier for me to do this problem, because I know a lot of you guys have said you've struggled with it as well. So first things first, in the top corner here I have the inverse square law for you, so that if you don't have it readily available you can jot that down quick. And then these values that I got that we're going to use for our problem today, I got from your first exposure worksheet. If you aren't part of the class or you didn't have that or don't have that worksheet right now, it still shouldn't matter, because again, I'm going to put these in step-by-step format, so you shouldn't need it anyway. Okay, so first things first. The first step I always do is I like to identify my variables. Okay, so what I mean by that is I like to pull these numbers and attach them to the numbers I'm given, whether it's in a word problem or formatted like this. That way I'm less likely to confuse them from one another. Okay, so the first one, 36, is your distance 1 squared. This is your intensity 1. You're solving for intensity 2. And 40 is your distance 2 squared. Okay? Second thing I like to do is plug them into the formula. The sooner I get my numbers put into the inverse square law formula, the less likely again that I am to put those into the formula incorrectly later in time. So I like to do that right away. So that would look like this. 250 millirem over unknown, so that's what we're solving for, intensity 2, over your distance 2 squared, which is 40 squared, over your 36 squared, or distance 1. Okay? Step 3, you want to cross multiply. And I like to write out in the formula lettering what that's going to look like. It helps me make more sense of it. So what that's going to be, and I'll just make little arrows because I do this too when I'm working, makes it make more sense to me, is that's going to be intensity 1 times distance 1 squared is equal to intensity 2 times distance 2 squared. Using the numbers that we've been given, that's going to be 250 millirem times 36 squared, which is equal to our intensity 2 unknown, times 40 distance 2 squared. Okay? Step 4, you want to isolate your variable. Oh, it's going to get close. What I mean by that is I want x to be left alone on one side of the equal sign. I don't want anything else hanging out with it. So what I'm going to do, I'm going to divide out that 40 squared. And I'm not actually doing any math on my calculator here. I'm just setting up my problem still. And that ends up canceling out these two 40s. At this point I like to switch my x to the left side of my problem. I think it's clean, looks cleaner. Having it backwards kind of drives me nuts, but it doesn't matter either way. So I would then put x is equal to 250 millirem times your 36 squared over your distance 2 squared, which is 40 squared. Okay? At this point, all you need to do now is solve. So like all good college students, using your scientific calculator, and if you don't have one, most cell phones, modern ones, have one that you can at least use this with, you would get x is equal to 324,000 on top over 1,600. Okay? So this equals the 324,000, 40 squared equals the 1,600. Then just divide these to each other. 324,000 divided by 1,600 gives you 202.5. So then your final answer is millirems needed for the 40-inch SID would be 202.5 millirems. Okay. That's all there is to it. Not too bad. You've done the inverse square law, 5 steps. Let me know if you have any questions.